Okay, having said that, now let's move towards our architectures. And first thing first, we are going to talk about autonomous one. What is the meaning? And this is what we have been discussing. We have discussed in the last class. We have access switches, we have distribution switches, we have our Anjali, and we have this basic service set here, right? Basic service set is identified by SSID, and maybe here the SSID is employee, Anjali is the employee, and similarly we have Mr. Rahul here, which is part of VLAN 10 right here, and SSID employee is here. As I mentioned, in case of autonomous, we also call it as distributed approach because nothing is centralized, everything is distributed. What is the meaning of distribution? Distributed. We have AP1 here. If I want to make it live, we have to configure this to broadcast an SSID. This SSID should be broadcasted on maybe some RF signal, maybe of 2.5 gigahertz or 5 gigahertz. We have to set the power, maybe 100 milliwatt. You can convert it to dB also, or the dBm also. I think you all know the process. I think it is going to convert as 20 dBm. We need to configure all these things. Channels, we need to all these things we need to configure. Maybe a management IP address of this access point. And here is somebody who is the administrator, right? He is very happy in configuring this AP, and then he needs to configure this as a trunk interface. If he's advertising to different VLANs, maybe VLAN 10 and VLAN 20, this trunk interface should be having 1020 as permit, maybe one address to manage this access point. Maybe the VLAN 99 is the management VLAN, and we need to allow this here. If you need to configure one or two such APs, that's not a problem. You can do it here. You can do it here also. What should be the traffic flow in this case? Traffic flow is going to be really easy, and I'm going to tell you three traffic flow. What is going to happen when Anjali wants to communicate to Mr. Rahul in the same VLAN? She has to send the .11 message from here to here toward this AP. AP will be converting .11 to .3. It will be reaching to access. Because of spanning tree protocol, maybe some links are blocked. Suppose this link is blocked at a particular moment of time. It will be going from here to here, and then from here to here. These are my trunk links, and the traffic will be reaching here. This AP will be converting them back to .11 from .3 based on those direction to distribution switch from distribution switch. And this is how these two guys are going to communicate with each other. Right? The second traffic flow is toward the distribution switch. Distribution system, when we talk to this guy, which is C, let me choose some another pan, maybe the purple one. Again, believe me, the communication will be simple from here to here. It will be like this, right? Going towards the access switch, because one link is down, it will be going here, right? From here, it can take path from here or from here, depends, right? Which one is open? Maybe this is the open one, and from here to it is going like this. Towards internet, what is going to happen? The traffic path till this point is going to be same. Let me draw it with the yellow or maybe the red one. From here to here, it will be here. It is going to be towards the gateway. And from the gateway, it will be flowing like this. There is no doubt about it. We can do it. Here, as said by Mr. Prakash, access point is doing some things, but it is doing everything, right? From trunking to conversion of .3 to .11 messages, publishing the SSID, maybe the security department thing, management thing, everything you are doing, right? On every AP, you need to do the same thing. Every AP is doing the same thing. That is why it is the distributed environment where every access point is autonomous. It is self-capable of doing things, right? There are many problems associated with it. For example, if we have VLAN 10 here, right? If we have VLAN 10 here, and suppose another building connect through the core, and you need to send basically on this distribution switches and then access switches, right? And you need to extend this VLAN 10. Believe me, extending of VLAN 10 is a problem, and you need to extend this VLAN, right? There are many issues with this autonomous thing. One is how you are going to manage if these access points are really large in number. Suppose you went to an IKEA store. They have a big warehouse, maybe where 200 people or 300 people are working, right? And you need to cover a lot of access point, maybe 1,000 access point, right? And if you want to do the manual configuration, the autonomous configuration, the distributed configuration on everywhere, it is going to be a nightmare for you, right? It's a problem. The main problem is the configuration and management, because you need to repeat a lot of things. And that is where Cisco thought it is going to be great if we have somebody which can sit in somewhere in the cloud, right, and can manage all of my APs from one place. I do not have any problem with the traffic path here. Traffic path can be same, but I do not want this nightmare, right? This is really a problem that all 1,000, 2,000, 3,000 APs I need to configure. What I want to do is that if I have maybe 100 APs which are broadcasting SSID employ, right, at 2.5 gigahertz, maybe at a power level of 200, or maybe, sorry, not 200, 20 dBm, right, and maybe channel number one, why can't I do at once all these things, right? Maybe there is one guy who can control all this thing. I need to configure here, and all the configuration is done. And that is what Cisco has done for a different architecture, which is known as the cloud architecture. It is another form, right? What they are doing, they are sending a controller, or they are having a controller in the cloud. This cloud can be your Azure, this cloud can be your GCP, can be Amazon Cloud Services, AWS, sorry, Amazon Web Services. If that is the case, what is going to happen? When this AP, maybe AP1, AP2, or AP3 comes live, they form a connection. And by the way, this is the same connection I was talking about, right? Or maybe a normal HTTPS connection, right? And if there is a connection between these guys, what you can do is you can have all the intelligence here. Means if you want to configure SSID, configure here. If you want to configure RF signals, configure here. If you want to configure all these trunk interfaces, configure here. And then once you are done, maybe you can push this on selected APs or all the APs based on maybe many things, right? This is what Cisco Meraki does, which is cloud-based solution for wireless infrastructure of an enterprise. Okay. But the important thing here is that there is no difference with respect to the traffic patterns which we talked about previously, right? It means that although all these AP can be managed and maintained from this WLC, right? But the traffic flows are going to be same. The meaning is, if this guy wants to communicate to Rahul, the traffic flow will be, sorry for this, will be same from here to here, from here to here, towards internet, toward whatever I showcased you previously. There is no difference between the traffic flow. But yes, we have a single pane of glass through which we can configure, manage, maintain all these APs from one single, which is maybe Cisco Meraki dashboard. Having said that, let's talk about another basic architecture, which is split MAC.
Sorry, Vishnu. For the Cisco Meraki part, does it mean that all the data traffic doesn't go to the controller in the Cisco Meraki, which is in the cloud?
You are right. You are right.
It just manage the all the APs in the infrastructure, but the real user data traffic goes between the APs in this case.
You are right. Your understanding is absolutely correct.
Okay. Okay. Thank you.
Perfect. Now, let's talk about one of the most frequently used one, which is the split MAC, where you have seen. Although, if you understand split MAC, right, then you understand basically the need of a flex connect, convergence, or the convergence model of Cisco, or the other model like centralized one. But you need to understand what is the meaning of split MAC. What we are doing here is we have a campus network right here. This one is my campus network, right? Because we have three layers here: access, distribution, and core, right? You can see access, distribution, and core. This is my C1, this is my C2, and I have connected this WLC to core of my switch. Suppose, by the way, Where you are placing this WLC now is going to define different Cisco's architecture. Believe me, I am going to explain you. Do not worry about it. So what I'm doing here is I have two different things. I have two different tunnels here. One is red color tunnel and the other one is yellow color tunnel. And I think by this point you understand these tunnels are just nothing but the IP, but the packet encapsulated in another packet. That's it, right? So I'm calling this red one as my control tunnel and this one as my data tunnel. What does that mean? When access point comes up, the first thing first, it is going to find where its management server is or where WLC is, wireless LAN controller is. And there are many ways to do that. We will be talking about them in next class, so do not worry about it. But when these comes, it is going to make a tunnel with the WLC, right? Over this tunnel, they can securely send messages between AP and WLC. What is the meaning? You all know that tunnel is just nothing but the packet inside another packet, right? We have 802.11 messages inside another one. So if I say I'm sending securely these messages, generally, if we do not secure the inner .11 message, means if anybody open this envelope, it is going to see this message, right? But the good part will be if I encrypt this message. The meaning of encryption is so that if anybody get this message also, he will not be able to understand it. That is why the meaning of security or encryption. And that is why we are going to introduce a technology here when we are making this tunnel, which is TTLS, which is transport layer security over UDP. If you do not get it, that is perfectly fine, right? And that is why I highly encourage you to just go ahead and read my course on Identity Services Engine or maybe network security from scratch, where I have discussed all these things like authentication, public key infrastructure, transport layer security, if you are really interested. Or what I will do is I will include those 5 or 6 classes here for your reference into this course itself so that you can read about it. Okay. But if I talk about them, believe me, this course is going to be really long and it is not going to cover. We are already into the 10th class. As I mentioned that this course will be only for 14th and 15th. It will go till 14th and 15th, apart from the hands-on videos which I will be uploading, which right. So overall, it is going to make a TLS tunnel where I will be encrypting these .11 messages also. What these messages are? These messages are means that once this access point is coming up, right? It is going to find its WLC, make this red color tunnel, and then they can send messages securely over this tunnel. What are those messages? If this WLC want to say, hey, Mr. AP1, you need to advertise SSID employee. This guy is going to advertise SSID employee. Then WLC say, Mr. AP, you have to do that on 2.5 gigahertz as well as other or maybe 5 gigahertz channel, right? And it is going to do that. Maybe you need to do it with a 20 dBm power. It is going to do that. Maybe it can collect information from this access point. Who? WLC. All these things are going over this control channel where WLC is guiding access point, right? Or maybe access point can also send some control information, right? Like join messages and all, which we will be talking about pretty soon. But if you say, Mr. Vishnu, that is perfectly fine, but why this data tunnel is for? The data tunnel is for sending my actual data, means Anjali is saying hi to somebody over internet right here. What is going to happen then, right? If that is the case, then Anjali's traffic will be moving first towards WLC over this tunnel. If I say this tunnel, the whole sole difference between this one and this one, we will be talking about it, is the port on which they are working. This is working on, suppose, X port, then this is working on Y port. By default, the control connection is, or the control tunnel is always encrypted or using some security mechanism like TTLS, but the data tunnel doesn't use it. If you are not comfortable about the security TLS, that is perfectly fine. No worries about it. Okay. But I just want to say whatever is going on that this red link, which is the virtual link, actually everything is going on your access distribution and core. That is absolutely safe because inside on interior .11 message is actually encrypted. But on the data side, on the yellow one, it is actually non-encrypted. But it is not the case that you cannot do it. It is up to you. Means if you want to do that, you can encrypt your data traffic also. Okay, but who is going to do the encryption portion? Of course, your access point. So, enjoying learning? If you have reached till this point of the video, I think you are enjoying learning, and I just do not want to waste your time. I would like to say that if you want to see this complete course, this course is available on my website, which is www.bridgewire.com. Please have a look at it. And along with this course, there are so many other courses available. If you want to start your networking journey from the beginning, from the scratch, or if you are a seasoned networking engineer, please have a look at this website. So you can see here is my website. The link of this website is also available on the description area just below this video. Thank you so much and enjoy learning. We'll be encrypting .11 messages before encapsulating it inside the IP packet, as you all know. So what are the duties of WLC here? It is responsible for radio frequency management. It is responsible for authentication of the client, maybe the security, also the encryption, association, not encryption. Encryption will be done by the AP. Association, roaming means we will be talking about roaming also pretty soon, and the QoS requirement. And if I talk about the access point here, the responsibility of the access point is actually it is going to transmit what are the radio frequencies set by or guided by WLC, MAC management, and encryption. It means that previously your autonomous AP was doing all these things. Maybe if you want to upgrade your AP, this can be guided by WLC. Maybe WLC can push the image to this access point, right? Operating system management is also done by WLC. So what we are totally doing, what we are doing here, we are just distributing the responsibilities. Some responsibilities are going towards WLC, some going towards the access point, and this is what is known as the split MAC architecture of Cisco. And by the way, where you are putting this WLC, right now I have just connected it towards the core, but this WLC can be somewhere into your data center. Believe me, this WLC can somewhere which is very near to or just here on the access layer. All these access switches are your WLC. If that is the case, this resulted into different architecture at all, right? So if I talk about if your WLC is directly connected to your core or into the data center, we are talking about an architecture which is centralized architecture. What is the meaning? The meaning is absolutely simple. Whatever the data you are sending, doesn't matter if we have Rahul right here. If you want to send data which is connected to this AP, Anjali is connected to this AP, both are in VLAN 10. Doesn't matter if they are talking to each other, but the data is going to WLC first, and then WLC is sending back. I will be talking about this traffic flow, but this is what the centralized architecture means. If this access point is right there into your data center also, the traffic will be going towards this data center and then coming back. So now I will be talking about this centralized architecture, which is based on your split MAC, right? The basic is a split MAC because some responsibilities are done by WLC, some responsibilities are done by access point, right? So we are making access point lightweight. Autonomous were pretty heavy. They were doing everything. Here we are making them lightweight. So if we talk about traffic flow of Anjali, right, towards internet, how it is going to be? Just try and think. Definitely what we will be doing is Anjali will be sending .11 messages to here. And I know, we all know that we have a data tunnel formed between this guy and this guy. This is my data tunnel, right? Let me make it with some different color, maybe this one. But actual message, if you see, that goes from here to here, right? AP, what AP will be doing? AP will be taking this 802.11 message. It will be encapsulating it inside the cap web tunnel or whatever the tunnel it is, and it will be sending it here because normal IP will be flowing from here to here, from here to here, from here to here, and then it will be reaching towards my WLC. So although I can say the message is going over this tunnel, but actually the message is passing over my infrastructure. Once it reaches here, right? Once it reaches at this WLC, what is going to happen? WLC is going to open 802.11 message, which is inside this encapsulated IP packet, right? Or the tunnel. And then it is going to convert this into your normal 802. 3 message, because you all know from source MAC addresses or whatever we have this information we can generate. At the end of the day, .11 message is what? Inside it, we are going to have IP, TCP, and application data, which is high, right? Now this is going to be your normal message. What WLC will be doing, it will be sending it again back towards the core. And that is where WLC needs the connectivity, the full connectivity, then sending from here to here. And that is where how it will be reaching to your internet. If we talk about the traffic data path till to this computer number C, what is going to happen? Let me take another pen, maybe the green, maybe the magenta one here, the wallet one. It will be going from here to here towards distribution, right? Again, it will be reaching to what? WLC. Why? The reason is simple, because whatever you have, whatever access point have here, it is going to send it towards WLC over this red color tunnel, right? Although from this green and this wallet, I am showcasing you the actual data path, but generally people say it is going over this tunnel, right? The cap web one. Once it reaches here, WLC is going to convert into the 802.3 and it will be sending it back over the wired network from here to here and right here. And see another interesting traffic path from Anjali to Rahul this time. Suppose these are into VLAN 10. This guy is connected here over Wi-Fi. And now let's take another pen, maybe the blue color one. Okay, this is fine. This is not that fine. Let me choose this one. This is okay. Yeah. So Anjali will be sending it first of all towards again WLC right here. And WLC will be sending it back over this infrastructure and coming like this. The traffic is going and again coming back. This is what is known as hairpinning, right? I have explained you all the 3 traffic flows, right? And you must be thinking, Mr. Vishnu, if there are more traffic flows towards the internet, I think this model makes sense. Even if there are more traffic flows between internet and your computer C, which is on the wired portion, it is also making sense. But if there is a communication between Rahul and Anjali, which are connected in the same SSID, right, then this model is not making much sense, Mr. Vishnu. Then I agree. And that is where we have different architecture for that. But if the most of the traffic is towards the internet or towards this host C in the wired, this makes sense. And that is where you see this thing many times, right, in many environments, that you put WLC right there into the campus core, and that is doing all these things. By the way, if you're thinking that, Mr. Vishnu, your whatever the solution you just built is not robust, not reliable, because you have only one WLC, we can have multiple WLC, and there is a concept of primary and secondary WLCs, right? But we can talk about it. But I think with this point, you can understand the more centralized architecture. People also put this WLC into the data center, and then you must be thinking, Mr. Vishnu, don't you think it's a problem? If it is in the data center, then generally my data center and my campus network, and there is a WAN network between them. Are you saying that if somebody wants to go to the internet, first the traffic will be coming toward the DC where my WLC is, and then it is going? This is fine. This is not a problem. But if somebody wants to communicate to a server which is right there in your campus, then it's a problem. Your traffic will be going towards DC, then coming back. You are using WAN to communicate inside your campus network. This is the problem. And that is where we have other architectures also, right? But centralized means you have one place, WLC, where you are sending all the data traffic. Control traffic is already with the WLC, right? But you are sending all of your data traffic, and then WLC is redirecting it towards anywhere else. And that is why the connectivity of this WLC is really important. It is connecting towards the core. From there you can send the traffic anywhere. If it is looking a little bit difficult, do not worry, guys. Do not leave the basics, right? If you're not getting this traffic path, then there must be some problem with the basic routing and switching. And that is the whole intent I had in this package. If you have wireless, I have put switching fundamentals also and routing fundamentals also. If you know that, these things are going to be pretty easy. Most of the wireless engineer know how to configure WLC, but they do not know where exactly they are fitting their wireless infrastructure into the complete picture. I just wanted to make a complete picture for you. Having said that, now I would like to talk about the next one, which is the converged access, right? And the last one is going to be Flex Connect, but we will not be talking about Flex Connect today. because it is going to take a lot of time. But Mr. Nitin had a question. So Mr. Nitin, let me complete this board of the converged access, and then we can talk about, right? So you must be thinking, Mr. Vishnu, I think that that is a problem, that all the data needs to go to the WLC and then come back. So that is for that what Cisco has done is that they are saying that we have made a architecture for you. Means if the most of the requirement is right here, then why don't you have the converged access? What is the meaning of the converged access? If I talk about these access switch in a particular floor, maybe a particular floor can have 4 different access switch, and we can have all these access switches in a stack. If you see the stack particular structure, it is just saying making a ring-like structure. And now these 4 switches are not 4 switches. These are just a single switch. So Cisco is saying, why can't you, instead of putting one WLC here and sending all the traffic from here to here and coming back, if the traffic flow requirement is between them a lot, right? Servers are also here also, right? Then why don't you put your WLC functionality right into these access switches or stacks of switches? Interesting, right? If that is the case, I have a small data tunnel from here to here, and WLC is right here. It can send my traffic anywhere, right? By the way, it is not the control and data tunnel. Sorry, there are going to be both control and data tunnel, right? Because once this AP comes, it is going to make the control tunnel, and we will be, and there can be other APs also which can be connected through this stack, right? Not one, maybe 5, 6, 7, and you are managing and maintaining them using this access point. But the problem with this model is, again, you are having a distributed architecture. Now you are distributing WLC's responsibilities, right? Here we have WLC which you need to configure. Here we have WLC, and here also we have a WLC, right? You need to wait. See, Cisco offer you this solution also if you want to do the converged access. We have switches which are WLCs also, right? If you do not want to have the centralized one, if you do not like that hairpinning, or if you do not like, of course, you are not going to like if my two parties are communicating and there is a lots and lots of traffic between the access switches. Why would on earth I want that my traffic should go WLC in the data center and then come back? It's a problem. I'm not saying you need to use converged one or the centralized one. It depends. It depends on what the traffic flow is, right?